So let's solve this exercise because it's not so easy, because you have two stochastic processes, x, y, even three. You have winner process, a yt dt plus xt dwt. And we have some initial condition. X0 is some constant, and y0 is 0. And the question A says that we need to find the solution of this stochastic differential equation, but not all solutions, but only solutions with some specified form. So xt is given by some deterministic function times cosine of wt, and yt is some other function deterministic of t times sine of wt. And we need to find the solution of a given of this form.
This is g function, yes, in the bottom, j.
Yeah. Let's go. So basically, how do we solve such problems when we have a structure of equation of solution given? Basically, we just plug in and we apply it as lemma. Basically, the strategy is very simple. Just a moment, because I think the connection was lost. Okay, so the strategy is more or less direct. We just plug in proposed solution into the equation. Let's do it. So according to Ito's lemma, what is dxt? According to Ito's lemma, let's recall it.
It's
so
f
we
prime
need
t
to
times cosine omega t.
F prime t times cosine wt times dt plus.
Yes. No, it will be minus ft times sine.
Yeah, I have not. It will be the derivative of cosine is minus sine.
Wt wt plus minus 1/2. Yeah, ft.
Yeah, I prefer to write like that, like this. Yes, you're right.
Minus cosine wt dwt squared.
Okay, yeah, you are completely right. I agree. And yeah, any questions? There is, but this is just basic idea that if we have a function h of t and wt, then dh is h prime with respect to t times dt plus h prime with respect to w times dwt plus correction, Ito's correction, that is absent in ordinary differential, h prime prime with respect to ww dw squared. Okay, that is basically its lemma. Okay, let's simplify it a little bit because we will have that part can be simplified. We can add these two parts together because we have symbolic rules for its lemma that dwt squared is just dt. Dt times dt is 0, and dt times dwt is also 0. Okay, we have some symbolic rules. These are not honest mathematical objects, but there are some symbolic rules to make computations easier. Okay, so we simplify dxt. Dxt is just, let's write two parts, something times dt plus something times dwt. For dwt part, we will have let me copy
Sine wt
just f prime cosine minus cosine
1/2 f cosine
f prime t cosine wt minus 1/2 f
f
of
of
t
t
cosine of wt, and here I will have f of t times minus sine of wt. Okay,
Yeah, sure.
just its lemma, and I do the same thing with the second equation. dyt, I recall that yt in the proposed solution has j of t times sine of wt, and I have so g prime times sine of wt times dt plus j of t times cosine of wt times dwt plus 1/2 j of t times
Minus
minus
sine
sine wt times dt, because that guy is just dwt squared. Okay, so basically this is application of its lemma, and I have original equation. Equation says that dxt should be equal to axt dt minus yt dwt. dyt should be equal to a yt dt plus xt dwt. But both representations are correct. So I immediately obtain 4 equations. But these 4 equations are ordinary equations. There are no dt. So this is just a short term for something real.
Why are they ordinary, since there is like the prime, f prime, g prime?
Yeah, I mean they are meaningful. Yeah, not maybe not ordinary. I mean that each term in these 4 equations is meaningful. So dxt does not exist, but when I will create 4 equations, so first equation will be before dt in dxt. Second will be before dwt in dxt, and I will say the same thing for yt. So what is before dt in dx? it's f prime cosine w minus 1 over 2 f cosine w, and that should be equal to a xt. From the other hand, f times minus sine of w should be equal to minus yt. I mean, these equations are honest. So yt is a honest mathematical object. It's a stochastic process. So what are the two expressions for dt in dyt? From one side, I should have j prime sinus sine w minus 1 over 2 j sine wt. From the other hand, that should be equal to a yt. And the last equation before dwt in dyt, I have j times cosine of w, and that should be equal to. Sorry. What is your question?
It wasn't a question.
Okay. J times cosine of wt, that should be equal to xt. Yeah, I have 4 equations, and I need to solve them. Let's solve them.
Like the Unix system, right? All the four
Yeah.
equations.
Yeah. We need all the 4 equations. But that's a good point. Yeah, we have removed all these Ita's tricks. Now we have something we need to find, just deterministic functions f and j. So basically we have 4 equations for 2 functions. But let's try to solve. Yeah. Okay. For example, I think I will get rid of x using 1 and 4. I can get rid of x, and using 2 and 3, I can get rid of y. So if I let me sum 1 plus a times 4. So if I sum, subtract, yeah, minus, I will get 0 in the right hand side. So I have f prime cosine of wt minus 1 over 2 f cosine w minus a times j cosine of w is 0. Or f prime minus 1 over 2 f minus a times j is 0.
Why cosine wt can be 0?
But that should be for every t. For every t. Cosine of wt obviously can be 0 occasionally. Yeah.
Yeah.
But we say that this is for every t, this is for every t, that is for every t. So yes, you are right in the sense that cosine of t can be sometimes, cosine of wt can be sometimes at some points, it can be 0, yes. You're right. But we are searching for some continuous functions for which this always holds.
Okay, got it.
Okay? So it's not sufficient to have some points killed by cosine. Okay, if I get equation 2 multiplied by a and add equation 3, yt will disappear. And here I have af minus sine w plus j prime sine w minus 1 over 2 j sine w. I get rid of sine by the same reason, and I have af plus j prime minus 1 over 2j equals to 0.
Excuse me, can you please once again explain how do you remove sines?
Sine can be 0 sometimes, but my equation should be 0 for every t. And if the function is continuous, if it's 0 around in the neighborhood of a point, then it will be 0 in that point.
Oh, I get it. So you could instead insert 1 or 1 to 2, yes? Half, I mean.
Where?
Well, instead of sine.
Yeah. Okay, now what else? Now we have a system of ordinary differential equations. J prime minus 1 2 over j plus af equals to 0. Now we can take a and move it in the second equation. So I'm aj equals to f prime minus 1 over 2 f. I multiply this equation by aj prime minus 1 over 2 aj plus af equals to 0. And I plug in there.
It's alpha squared f.
Sorry.
You multiply by alpha, and it becomes alpha squared.
Yeah, you're right. Okay, so it's f prime prime minus 1 2 f prime minus 1 over 2 f prime minus 1 over 2 f plus a squared f equals to 0. What else do I have? I have f prime prime minus f prime, sorry, plus 1 over 2 f equals to 0. Yeah, am I right? Or
Seems
It
so.
should be 1 over 4. No?
yeah, 1
Yeah.
over 4. Mhm.
I'm sorry, can I ask you a question?
Yeah.
Can you show 4 equations? I have a question about the second. It's equal to minus yt or it's equal to minus xt? I can't
Let's
understand.
check. Maybe
Second one.
second one, what is the before dw in
Yeah.
dx?
Yes.
Before dw in dx, from 1 we have that part.
Yes, it's clear. And it's equal to minus.
dw dx.
I got it. Thank you.
I may do some mistakes. That's okay. Just be brave if you see that that something is wrong. That may be, no problem. Okay, so what do we have? J cosine W. Cosine xt is J cosine. Okay, let's go on. We need to solve this equation. Yeah. Let me check. Maybe we can do better, because it seems too long for me. Can we do better than that? Cosine. If we get there, yeah, I think that. Yeah, that seems. Xt, we know it. J cosine we plug in. Okay. We have one equation. We plug in there. Yeah, that seems that's okay. We can do better. Okay. Now let's solve this equation. How to solve that one? Let's move on to the next page.
It is like differential equation with constant coefficients, so we know that the solution will be in the form of e to the power to some power.
Squared. Yeah, like that, like that. Yeah.
So we can make the characteristic equation, but
Yeah,
you're
let me check
mistaken.
that
It's
our
minus.
equation. Minus f prime plus. Like that.
Maybe minus.
Minus or minus. 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 Why minus? Let me check. Maybe you are right. But I don't see. Maybe there is a mistake, but where it is? 1, 2, 3, 4, 5, 6. Where it is?
I don't see it now.
Maybe I don't know. Okay, let's go. Let's try to finish. Okay, how do we solve it? We have a d that is equal to 1 squared minus 4 times 1 over 4 plus a squared. Yeah. And we
Yes.
have minus a squared. Yeah.
Yeah.
So when the determinant is negative, what is the form of solutions of ordinary differential equations? So if, for example, you have two roots,
it's e to the real part.
5 and minus 5i. What is the?
Use cosine sign in front of it.
Yeah. And in this case, you will have a solution f of t like c1 times cosine of what?
5t.
Yeah, cosine of 5t plus c2 sine of 5t. Okay, let's go on. Continue in. So let's assume that we can safely assume that a is
Wait a
greater
minute.
than.
It should be minus alpha to alpha squared. Minus 4 alpha squared.
Minus 4, but never mind. It doesn't influence. So we have either the root is I times 2a, either the root is minus I times 2a. Yeah, we have two roots. Yeah, because if I take I to a squared, I get minus 4a squared. Yeah? Okay. So my roots, lambda 1, lambda 2, are 1 plus minus I to A divided over 2. It's 1 over 2 plus or minus IA. Yeah. Okay, so in my case, the solution is f of t should be equal to C1.
E. Shouldn't there be e to the power of 1/2 t?
Yeah. It should be exponent of 1 over 2 t times C1 plus times C1 cosine of AT plus C2
Fine.
sine of AT. Okay.
Excuse me, in the roots, I is multiplied by 2a, yes?
Yes.
Okay. Thank you.
Yeah. Okay. And J of t equals to what?
The derivative minus 1/2 of the function.
Yeah, it is, as far as I remember,
And divided by a.
it is there. Yeah. It's f prime. Oh my, I forgot. Man.
F prime minus
Minus 1/2 a.
over
Minus
A.
1/2 divided by a, yeah?
Yeah.
Without whiteboard, it's a little bit tough. 1 over 2f and divided by a. Okay?
Yes.
Basically, ding, 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 ding. Basically, what we can do, but that's the answer, yeah. So I'm a little bit lazy, but we have solved. But we may finish it. There are many strategies. I prefer working with complex numbers, but you may finish like this. Yeah, f prime will be equal to. Should I finish? Yeah, or you understand that basically we have found f. We have found.
The logic is clear.
So
Yeah.
the task was to find ft and gt, right?
Yes, because xt is given by ft times cosine of wt. So the task is in point A to find just find the missing pieces of answer. So ft and jt.
Excuse me, when we take a derivative of ft, there will be no dt's, yes?
No, what?
dt.
No, there are no dt in the no. So if you like, we can do it. A little bit boring. If we went to real numbers, in complex numbers, it would be easier to work. But anyway, so what is the derivative? It's the derivative is 1 over 2 first derivative of z1 ft, yeah, plus exponent of 1 over 2t times, I take the derivative of inside brackets, it will be minus c1 cosine of at plus c2 sine of at multiplied by a minus f over 2 times a. And everything will disappear almost. So this term will cancel out. A will cancel out. And I think the only exponent 1 over 2t times minus c1 cosine of at plus c2 sine of at will remain. Yeah. So
We
basically,
need to
this is
definitely switch the C1 and C2 parts,
why.
because when we
Ah.
take the derivative of cosine, we
Yeah,
need we get sine.
Derivative of cosine is minus sine. And that is cosine. Yeah, you're right. Yeah, like that. Okay. So for the point B, any questions about A?
No,
Okay, let's move on to B. Prove. So we have found all the solutions. So there are many solutions. Yeah, you may plug any C1 and C2. So there are many solutions to this stochastic differential equation.
why are they many? Since we have two initial conditions.
No. There are many. C1 and C2 are arbitrary. You just take C1 42, C2 2020. You got one solution. You plug in C1, C2, hop, other C1, C2, you get other solution. Okay, we have found infinitely many solutions, and not all of them. There are more solutions. Okay.
Wait, no, we have initial conditions, Cauchy conditions, like
Yeah,
x0
we have
ends with
initial
0.
conditions. Yeah, we have initial. Yeah, you are right. We have initial. I forgot about them. Yeah, you're right. I forgot about initial conditions. So yeah, we need to find, yeah, that will contradicts initial condition. Yeah, you're right. I forgot about them. Yeah, there are conditions that
x0 equals
the 0
x0.
is given and y0 is 0. Oh, maybe it was simpler to, yeah, it was a little bit simpler to solve, yeah,
I'm
because,
sorry,
yeah.
may I ask a question?
Yes, you may.
Is here 1 over 2f in the beginning of GT?
Yes. When you need to take derivative of the first term and multiply by the second. Okay.
Okay.
So what will be if you take the derivative of the first term? It will be 1 over 2 exponent times second.
Yeah, and multiplied by this stuff. Okay, yeah. Understood.
And it will give me, and it will cancel out exactly with the second.
I see, thank you.
Yeah, I forgot about initial conditions, and with initial conditions, it was a little bit simpler because here we can say that, can we simplify it a little bit? Yeah, we can, I think, no, we cannot simplify. No, I don't see how we can simplify. Oh yes.
Excuse me.
Okay, let's be rigorous. Okay, let's finish our calculations there.
Can I ask you a question?
Yeah.
Can you once again, please, a little bit? Can you go up a little bit, please? Yeah. So when we take derivative of x1 to t, shouldn't it be just x1 to t multiplied by 1 to 2? No.
Sorry. What is your question?
Well, we take a derivative of f, yeah, right?
Of f, yeah.
So shouldn't the first part be like x1 divided by 2 multiplied by t multiplied by 1 to 2?
Yes, it is. And the second term.
So f is x.
No, f is all these two terms.
Ah, I see. Now I see. Okay, you just shortened the writing. Okay, thank you. Now I understand.
Yeah, because if f is a times, no, a is a bad idea to write it here. F is, I don't know, q times p, then f prime is q prime times p plus q times p prime. But in our case, q prime is 1/2 qp plus q times p prime, and it will be 1/2f plus q p prime, like that, yeah? Where q is that function and p is the second term, yeah? Okay?
Yes.
So let's work with initial conditions. x0, 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 x0. So our x0 is f0 times cosine of w0. So it's just f0. And y0 is y0 is j0 times sine of w0, and it's 0. So this equation has no information. Yeah, has no information for me. And from f0, I can calculate. F0 is just, what is f0? Is exponent 1/2 times 0 multiplied by c1 cosine of 0 plus c2 sine of 0, and that should be x0. And I see that c1 is x0 times what? Times
Times 1.
exponent minus exponent is 1. Yeah, c1 is just x0, and c2 is free. Yeah. Okay.
So it's just any number, right?
Yeah.
We can find it.
C2 is free.
Excuse me. So is x0 equal x0 or f0?
Doesn't matter, because cosine of 0 is 1. So both statements are true.
Okay, thank you.
Excuse me.
Yeah.
Could you say, please, why does f0 equals x0?
So let's start with first, then second, then third, then fourth. Start with first equation. Is it okay?
Yes.
So x0 is f0.
No. Wait. Why is it so?
Boy,
Because
it's given in
W0
the text that xt is ft times cosine of wt. It's given in the text. So it's a hint in the text of the problem. Xt is ft times cosine of wt. It's given. We do not discuss.
Okay, got it. Thanks.
Okay, and finally we have a solution, infinitely many solutions, yeah? So xt is just exponent of 1/2t times x0 cosine of at plus c2 sine of at. Yt is exponent 1 over 2t times minus x0 sine of at plus c2 cosine plus of at times cosine of wt times sine of wt. Yeah. And I think everything is satisfied.
Yeah,
Okay.
sure. Same answer.
And point B, we need to check that dt that is equal to x squared 2 plus y squared 2 is non-stochastic. Basically, there are two approaches to do it. I may just use the answer. No, I may not use the answer because it's written for any solution. So be careful that we can just take the answer because we have not proven that we have found all the solutions. We have found infinitely many solutions, but it's a little bit hard to work with. So there are some uniqueness conditions, but they are violated in this case. We have found already infinite amount of solutions. So to solve honestly point B, we cannot refer to our solution. We need to refer to original equation. Okay? Do you understand why? We just cannot plug in our solution in xt and say, whoa, Wiener process cancels out.
Yes, because it's only one of the solutions.
No, not one. We have found infinitely many
I mean,
solutions.
like,
Yeah. But there may be other solutions.
yeah.
So maybe there are many more solutions and we have found our solutions. And more solutions. Okay. Now we just calculate differential of dt. It is xt dxt plus second derivative 1 over 2 times 2 times dx squared plus 2 dyt dt dyt plus 1 over 2 times 2 times dyt squared.
But it's true. What tool do we use to find dt?
This is my strategy.
We just randomly picked up how you find dt?
No, it's a strategy. Plug in and apply it as lemma. I'm brave guy with one small sword and I will kill any dragon. Plug in and apply it as lemma. I have a short sword.
You plug in xt and yt, right, and apply it as lemma.
Yeah. I have no.
Then it's okay.
Yeah. So
Really brave. Really brave.
basically, the strategy is very simple. I have no atomic bomb, so I have only one sword. It is lemma. So I'm brave knight, and I will kill this dragon with a short sword.
Sounds like a plan.
Yeah. So only one strategy: plug in and apply it as lemma. Okay. dxt is given, dyt is given, dxt squared. So let's begin. 2xt times what? Times axt dt minus yt dyt plus dxt squared. I plug in and apply this lemma. Xt dt minus yt dwt squared plus 2yt. What is dyt? Dyt is ayt dt plus xt dyt plus ayt dt plus xt dyt squared. Okay, let's move on. And I see that a lot of terms will disappear. Yeah, I see.
А у ребят, слышно меня?
Да, это, видимо, не
Да,
мы.
это
Алекс, тебя слышно, а ты меня слышишь?
Федор Павлович, организатор, и идется запись. На твой комп, кстати.
Лекция кончена.
Ну что, математики решаем, получается?
Меня так бесит, что нету вот этих вот обычных учебников. Я так по ним соскучился открыть и просто прочитать.
Теперь Мейлис организатор.
Все, Федя Павлович, сейчас ты будешь принимать организатора.
Я тебе его обратно кину.
Бля, как его тебе кинуть?
Получил. Это какая-то игра в горячую картошку или что, блядь, у нас тут? Да, только с двумя
Да.
участниками.
Подожди, а нельзя скинуть организатора через верхний правый угол? Ой, то есть верхний левый, там на информацию, типа данные конференции.
Не, это все делается проще.
Все, я скинул.
Мне кажется, он не зайдет обратно, что он задачу решил почти.
Я даже скинул. Я немного мискликнул. Я не понял, он вместо XT и YT поставил просто эти выражения, правильно? И применил эту лемму лемма, да?
Да-да-да, то, что в самом начале было еще.
Когда он потерял синус и косинус, или он пока до них не дошел?
Не-не, он не будет их, наверное, вставлять. У нас же, типа, цель доказать, что там остается DT.
Подожди. У нас вначале была система, да, какая-то система.
Да.
А теперь у нас просто какой-то DT. Что это значит вообще?
DT был given, он взял производную и просто сунул туда.
Ну, ты понял этот переход от DT к DDT?
Ну, типа это слемма, которая, да?
Да.
Ну, по формуле, наверное, пойму.
Ну, и получается, у тебя там есть dxt в квадрате, dyt и dyt в квадрате. И вместо них, короче, вставляешь то, что было в самом начале в системе.
Те три штуки, да, которые?
Да.
И как понять, что он стохастик?
Там будет DT, там будет что-то DT. И это означает то, что там есть не то, что тренд, а то, что он тогда объяснял. Но, в общем, это не стохастик. Нет, стоп, я тупой. Не стохастик, это значит, там не должно быть DWT. Там не должно быть DWT, То есть не будет этого itas integral. То есть это будет deterministic function. Понял?
Еще раз, у non-стохастика нету DVT, да?
Да. Наоборот.
У стохастика есть DVT?
Да.
У стохастика есть DT.
Стохастика из 9, наоборот.
Нет. Да, у стохастика 9. Да блин, короче, все, меня запутали.
Где
Один раз
стохастик,
можете
там
нормально
WT.
сказать, прошу?
Где стохастик, там WT, потому что WT это случайный процесс.
Так, можно кто-нибудь еще раз? D большое DT. Как мы там получили его?
По италеме.
Не, смотри, я понял, что прикол. Короче, мы нашли решение до этого, потом нам дают DT и говорят, проверь, это переменная, которая построена из этих вот решений. Она стохастик или не стохастик? Вот мы представляем эти штуки, берем, делаем итаз-лему, а потом мы смотрим, есть у нас ВТ в любом варианте, там ДВТ или просто ВТ, и если у нас есть хотя бы одно из них, то у нас стохастик. Если их обоих нету, то нон-стохастик получается.
Ну вот какие штуки мы вставляем? Там же экспоненты, синусы, косинусы.
Подожди, пока никаких экспонентов, синусов, косинусов нет. Ты
Лёша,
просто так пока реши с xt, dt и dwt.
А кто мне админку дал?
Лёш, вот то, что ты сказал по италеме. У нас там просто из-за того, что нету t, собственно, нигде не... Ну, поэтому идет dxt, потом dxt в квадрате только, правильно понимаю?
Да, правильно.
Да, супер, спасибо большое.
Так, ну сек, но итаз-лема у нас нужно найти переменную по t и по wt.
Ребят, кого кикнуть, выбирайте.
Осуждаю.
Да, в всякий случай. Не, ну мы, подождите, мы в итоге вместо
Подожди.
типа xt представляем... Я просто, если честно, еще раз можете, пожалуйста, объяснить, Леша, типа DDT это как мы получили?
Что? Что именно?
Как мы получили DT? Это итаз-лема, но...
Ну смотри, у тебя, короче, вместо dt и dwt есть теперь две переменные. Блин, где эта италема была? Сейчас, подожди.
Может, ты
Мы
включишь?
раньше как представляли, что у нас есть какая-то xt, которая является функцией от t и yt, правильно?
Вот WT.
Ну, короче,
А вы к DT вернули?
да.
Что?
Зачем ты всех замьютил?
Кого я мьютил? Ты же говоришь.
Ну, сейчас уже нет, но до этого да.
Так мы типа все закончили теперь?
Ну, мне кажется, он не вернется.
Ну, он
Ну,
написал, что он запостит типа решение.
Он не вернется. Нет, Борис.
Он пришел почти вовремя, так что все, пора пораньше закончить.
Петь под запись, так что be careful.
Не, он сегодня на 10 минут опоздал опять.
Я теперь понял, почему Засорин не выкладывает.
Народ, а запись у меня будет или у кого?
У тебя, походу.
А, ты монополизировал Stochastic Calculus и запись на него.
Ну ладно. Блин, а можете кто-нибудь еще ее сохранить, потому что я с этого компа не смогу ее в телегу кинуть.
Мне кажется, она записывается на облачное хранилище. Не на компьютер вообще записывается.
А, ну да, есть такое.
Так, может, остановишь запись?